Happy Monday. We are going to start with our fair game review today. What I'd like you to do is start by looking at this set of numbers here, okay? And what we're going to do is we're going to calculate the mean, median, and mode, even the range of this set of numbers. Now, if you remember, these are called measures of central tendency because it basically measures where the center of the data is, okay? Now, we're going to look at this a couple different ways, and then Wednesday and later next week, we're going to talk about why we would look at certain things, or why we would want to have the mean versus the median, okay? The very first thing that you always want to do when you have a set of data, you want to put these numbers in order from least to greatest, okay? So I'm going to start with the smallest number. I'm going to cross it off. So I'm going to rewrite this as 13, 14, okay, 15, and 2 16ths, okay? Now, in order to calculate the mean, median, mode, and range, so the mean, okay, this is when you add all the data and divide by the number of data. Okay, so that means we're going to add all these numbers together. So we're going to add 13 plus 14 plus 15 plus 16 plus 16. And believe it or not, that's going to give us 74. Okay, then we're going to take 74 and we're going to divide it by how many pieces of data we have. 1, 2, 3, 4, 5. So we're going to divide by 5. Okay, when you put that in your calculator, you should get 14.8. Now that's the mean. Okay, we oftentimes call that the average. Okay, the median is the middle of the data. Okay, the best way to find the middle of the data is to cross off the outside numbers until you're left with the number inside, okay? So for instance, if I cross out 13 and 16, then I'm going to cross off 14 and 16, and what I'm left is 15. So the median is 15 because it's the middle. Median, middle. Think about median. If you're driving down the street, the median is what separates the two different lanes of traffic. Okay, so the mean is the average. It's when you add up all the data, divide by how much you have. The median is the middle. Okay, the next one is going to be the mode. Oops. Mode. Okay. The mode is the number that appears most often. Okay. Well, let's see. 13 shows up once, 14 shows up once, 15 shows up once, but 16 shows up twice. So that means the mode is 16. Yes, you can have more than one mode, and we'll talk about that later. Okay, the last thing that we're going to do is called the range. Okay, and this is the largest number minus the smallest. Okay, so that would be 16 minus 13, which is 3. So the range is 3. Okay, so that's your range. That's the difference in all of your numbers. Okay, the mode is the number that appears most often. Mode, most, mode, most, mode, most. Median, middle, median, middle. Mean, okay, that's your average. All right, we will practice this more in the next couple weeks. All right, let's write our learning target down for today. Our learning target is going to be, we will solve one-step equations using multiplication and division. Okay. All right. So if you remember, okay, We did this, okay, we did this by isolating the variable. We're going to isolate the variable using inverse operations. Ooh, barely fit that, okay? So we isolate the variable using inverse operations. Now let's review what we did last week with adding and subtracting just a couple times, okay? So our first couple of examples are going to be addition and subtraction, just to remember what we did. So let's say that I have something like n plus 13 equals 20. Okay, now in my brain, I'm probably going, some number plus 13 equals 20. In my brain, I should be thinking that that number should be 7 because 7 plus 13 is 20. So it's our job to use algebra to prove it. Now, one thing that you can do, that I do, is I draw, and this only works for some people, is I draw bars around my equal sign. Okay, just to remind me that everything over here has to stay balanced or equal to everything over here. Okay, and that just reminds me to put my equal sign in between also, because I've had a lot of students miss that. Let me show you what I mean. So I know that right now n is being added by 13. We want to isolate the variable, get n by itself, by using the inverse operation, or undoing add 13. How do you undo add 13? Well, you subtract 13 to both sides. Do you see how you do that to both sides? I also draw this equal bar right here because I'm saying, hey, this equal bar right here says you better do some math. And the math that we're doing is saying if I have plus 13, but then I take 13 away, those cancel out. That's 0. So I'm left with n equals 20 minus 13 is 7. Well, that's really good news because I really said that I think that n should be 7 in order for this to be a true statement. So as always, we want to check our work. And we check our work by rewrite the equation, substitute, simplify. So I think that n plus 13 will equal 20 if n equals 7. Rewrite the equation. Okay, so 7, you can put that in parentheses or not, plus 13 equals 20. Now what I'm going to do is I'm going to simplify. 7 plus 13 is 20, which equals 20. Boom, that means I did my work right. Okay, all right, so let's take a look at another one. And I want to be very clear that if you're adding and you have something like this, here's another example, 3 plus r. Do you notice how the variable is on the right side? That's okay. 3 plus r equals 12. Okay, I'm going to do the same thing. If you want to draw these bars, you totally can. You don't have to. It just helps me to remember to put that equal sign in there. Oops, and I also like to circle my answer. All right, so right now what's happening to r? It's being added by 3. Okay, we're going to isolate the variable using inverse operations. How do you undo add 3? You're going to subtract 3, but remember to subtract 3 from both sides. You have to do that. You have to keep that the same thing on both sides of the equation. Equals, well, let's see, 3 minus 3 cancels, because if I have 3, but then I take 3 away, I have nothing. So I'm left with r equals, and 12 minus 3 is 9. Okay, so I think that 3 plus r will equal 12 if r is equal to 9. Now, you guys can probably do that in your head and say, yeah, I'm correct. Why am I checking my work? Well, whenever we introduce a new topic, we always do that with numbers that you can do in your head. But remember, this is going to get harder. It's going to get more challenging, so we want to make sure that we have the skill down. So let's go ahead and check our work. So rewrite the equation. 3 plus r should equal 12 if r equals 9. So 3 plus, substitute, 9 equals 12. Simplify. 3 plus 9 equals 12. 12 equals 12. So I am good to go. Okay. Let's do one more example with subtraction, and then I'll show you multiplication and division. Okay. All right. What's going on with me? There we go. Okay. what if you had something like this? 10 equals x minus 7. X equals, 10 equals x minus 7. So again, you don't have to draw these bars. I sure like to, and it helps me remember that equal sign there. And what's happening is I have 10 is equal to x minus 7. It doesn't matter that most of my equation is over here, okay? And my variable's on the right side. It doesn't matter. We can still solve it. So I'm just going to say, what's happening to x right now? Well, it's being subtracted by 7. How do you undo subtract by 7? Well, you add 7. As a matter of fact, you're going to have to add 7 to both sides, because what I do to one side, I've got to do to the other side. And then I like to draw this equal bar. Really, I draw the equal bar only for addition and subtraction, because we usually add and subtract vertically like this. So let's see. 10 plus 7 is 17 equals, well, if I'm taking away 7 and I'm adding 7, I have 0, so 17 equals x. Okay. So let's go ahead and check our work. 10 equals x minus 7 if x equals 17. 10 equals, let's substitute in 17 minus 7. Let's see, 10 equals 10. Good to go. All right. So let's see what happens. What does it look like? So here's where we're going to start with multiplication and division. Okay. Had to get those couple of examples in there so you got to see those, okay? So let's start with some multiplication. Let's say I had something like this. 4x, because this means 4 times x equals 20. Okay, 4x equals 20. So I'm going to go ahead and draw these bars. So right now what's happening to x? It's being multiplied by 4. How do you show, or how do you undo multiply by 4? Remember, the inverse of multiplication is division, so that means I'm going to have to divide by 4. Now, algebraically, we actually show that as a fraction. Okay, so this is where this one gets a little tricky. I'm going to show this as divided by 4. Divided by 4. Now, why would I want to do that? Well, if I look at this part of my, without the x there, I have 4 divided by 4, or 4 over 4. And 4 over 4 is actually equal to 1. So I know that 1 times x is x. So that's why you want to divide by 4, because if you're multiplying by 4, but then you divide by 4, it just becomes 1. Don't forget your equal sign. 20 divided by 4 is 5. And we should have known that too, right? Because 4 times 5 equals 20. So there's our answer. Let's check our work. So 4x, check. 4x equals 20 if x equals 5. So 4 times 5. Now look, you either have to put this in parentheses or put a dot in between, otherwise it looks like 45. Equals 20. 4 times 5 is 20, which equals 20, so we are good. Let's do another multiplication that way, okay? So how about 8u equals 72. So 8 times some number equals 72. Are you guys already thinking about what number times 8 equals 72? Are you thinking 9? Because you're probably thinking right. Well, let's see here. Let's go ahead and do that work. So remember, when we're going to divide both sides by 8, because right now u is being multiplied by 8, to undo multiplication, we divide by 8. We're going to do it as a fraction because we know that fraction bar means divide. So I'm going to divide both sides by 8. And the reason why is because when I do that, 8 divided by 8 is 1. And 1 times u is u, and 72 divided by 8 is 9. So that means u equals 9. And that's what I thought it was going to be. So let's check. 8u equals 72 if u equals 9. 8 times 9 equals 72. 72 equals 72 because 8 times 9 is 72. Okay. All right. Let's take a look at another one. What if you get something crazy like this? Okay, and this is going to happen. Let's say I have something like 2/3 x equals 4. Well, right now I'm taking x and I'm multiplying it by 2/3. Okay, so I want to show you a little side note here, okay? So I'm taking x and I'm multiplying by 2/3. So 2/3 x equals 4. Now, if I divide both sides by 2/3, okay, oops, you can't see that. If I divide both sides by 2/3, that's no big deal. I can do 2/3 divided by 2/3. Remember, when you divide, we really multiply by the reciprocal. So I'm really going to be multiplying by 3/2. And when you divide by 2/3, you really multiply by the reciprocal. So the trick is we want to multiply by the reciprocal when we're trying to get rid of a fraction. Okay? So let's try that. Since I have 2/3 times x, if I want to divide by 2/3, then what I really want to do is multiply by the reciprocal on both sides, because I know that if I have a fraction and I multiply it by its reciprocal, I'm going to get 1. 1 is the multiplicative identity, and 1 times x is x. So that helps me isolate the variable, because I can cancel the 3's, I can cancel the 2's, that becomes 1. 1 times x is x. Okay? Then I can put this fraction over 1. 4 times 3 is 12, divided by 2, okay, is 6. So I think that 2/3 of 6 equals 4. So we can check our work. Okay. 2/3 x equals 4 if x equals 6. 2/3 times 6 equals 4. Let's make that a fraction by putting it over 1. 2 times 6 is 12. Divided by 3 is 4. Since 4 equals 4, I'm good to go. Okay? All right. Let's take a look at what happens when we have a division problem and we have to undo division. Something like this. X over 5 equals 3. Well, in order to undo divide by 5, we have to multiply both sides by 5. So I'm going to do it like this. I'm going to do multiply by 5, multiply by 5. The reason why I want to do that is because if I put 5 over 1, look what happens. I can cross cancel the 5's. Oops, I forgot my bars. I can cross cancel the 5's, meaning that's 1. So I'm left with x equals, and that's what I wanted to do. I really wanted to cancel my 5, and 3 times 5 is 15. So that means 15 divided by 5 is 3. Let's check our work and see if we're right. So we have x over 5 equals 3 if x equals 15. 15 over 5 equals 3. 3 equals 3. Boom. Okay. Let's try another one. Let's try, I think I can sneak one out. I'll get in the sheet. All right. How about n over 7 equals 4? Some number divided by 7 equals 4. In your brains, are you thinking what number divided by 7 equals 4? Are you thinking that number is 28? Well, let's see if we can prove it algebraically, okay? So I want to isolate the variable by undoing the math. Right now I'm dividing by 7, so I'm going to multiply both sides by 7. Okay, when I do that, 7 over 1 becomes my fraction, and notice that that becomes 1. I am left with n, because look at this. If this is 1 and this is 1 and this is 1, I have 1 times n divided by 1, which is n, equals, and 4 times 7 is 28. Let's check our work. N over 7 equals 4 if n equals 28. 28 over 7 equals 4. Well, 28 divided by 7 is 4. Since 4 equals 4, I'm good to go. How about one more example, okay? How about x over 4 equals 10? What number divided by 4 equals 10? What number divided by 4 equals 10? Can you do that in your mental math? You're probably thinking it's 40. So let's see if we can prove it algebraically. So right now, x is being divided by 4. Okay, we're going to undo that by using the inverse operation. Okay, so right now I'm being divided by 4, so now I'm going to multiply both sides by 4. And do you see how I put 4 up over here, kind of diagonal to the 4? Okay, that's going to allow me to do the cross canceling, so that's why I do it that way, okay? All right, so when I put 4 over 1, I'm going to cross cancel my 4s. That's 1, 1, and 1. So I'm left with x equals, and 10 times 4 is 40. Okay, I haven't been doing a very good job of circling my answers, have I? So let's check our work. So if x over 4 equals 10, if x equals 40, so 40 over 4 equals 10, rewrite the equation, substitute, now simplify. Well, 40 divided by 4 is 10, which is equal to 10. Boom. All right, friends, and that is it for multiplying or solving one-step equations with multiplication and division. Have a great day.